Hello, Paul. Hey,
Hello, JJ.
how are you, sir?
I am doing wonderful. How are you?
Actually, I've had a rather interesting day. I actually tweeted about this a handful of moments ago. I had an issue between GNU and BSD said that literally shaved off an hour and a half of my actual development time. Like I was sitting trying to figure this out for an hour and a half, not realizing running sed on your laptop or a Mac and then running it in container, and that's a Linux container.
They're
The
different
dash I
things.
that yeah, the dash I does something completely different.
Yes,
So yeah,
absolutely.
yeah, I completely forgot about that, and I wasted an hour of my day debugging everything else apart from that.
Amazing.
Yes, yes. So I want to have some fun on our stream. So what? So first of all, who are you?
I am Paul. What do I do? I'm on vacation, so I don't know what I do. Usually I'm a managed OpenShift black belt at Red Hat. But today I am a jobless bum.
Nice.
And who are you?
Uh, I am also, I guess, on vacation. I mean, I guess I work tomorrow, but I don't really. So sure, I don't know. But yes, hi, I'm JJ. I'm a developer advocate for the IBM Cloud, and this is our typical Thursday stream where we do something kind of cloudy and or Kubernetes or OpenShifty, where Paul and I just kind of sit down for an hour and try to do something new or play with something that we're working on and kind of just do some engineering work at the same time. It'd be great if you're watching live, if you do a +1 or a hi in the chat, just so we know we're all coming through clear and everything's great. Before I start sharing my screen, because God knows I don't want you to try not to be able to see anything I'm doing. So that'd be great to see. I'll give it a second or two for people to say something. So
Question for you, JJ, while we're waiting. What
sure,
idiot called it pair programming and not friengineering?
that's a great question. That is a very good question. It is. It's when friends come together, great things happen. Great things happen. So, well, I guess nobody's watching us live, so that's cool. That means we can make even more mistakes than normal. Um, Today, we're going to take a little bit of a detour from what we normally do. I'm going to take advantage of this audience um, and talk about a blog post I just put out and a serverless app that I've built. Um, Paul and I have talked about it off stream a few times, but I've never actually shown him what I did. And what better time than now than me showing it to him and y'all at the same time. So bear with me for a second. I am going to make sure I don't have any secrets up or keys up. And I just lost Paul. Are you still there? There he is. All right. So let me bring up my screen here. And here we go. So this is the blog post that I was told to write about this. And here you go if you want to take a look at it in real time. But basically what happened is a few times I've talked about this on stream, but I'll just the TLDR of it is one of the responsibilities I have at IBM is I spin up workshop requests for developer advocates or client advocates or whomever inside of my organization that needs like Kubernetes clusters or OpenShift clusters or whatever. One of the disadvantages of this is that we have to have payment, and it's really hard to get the what's the word I'm looking for money approval to do it. So they created a team, which the team was more than just me at one point, but now it's just me, to kind of dole out clusters to people. Originally started out with a for loop, and it became an application. And then recently I was told to move away from something called classic clusters, which is the old software infrastructure at IBM, and move to something called VPC Gen 2. And in that process, I discovered that the easiest way to get VPC Gen 2 clusters was to use Terraform plans. We have a bunch of Terraform floating around in different places to kind of just be like, hey, you need N number of clusters with a VPC and all the jazz. Here's a Terraform that has pretty much everything you need to do. You just need to add a few more things. So this whole blog post kind of walks through that whole conversation, where I end up leveraging something called schematics to control my Terraform running. It really truly is a nice little gem. If you use Terraform at all inside of your infrastructures, schematics is the equivalent in a lot of ways. It's not 100%, but very close to Terraform workspaces, which is from Terraform Enterprise. And schematics is basically our version of that, that slurps up Terraform and controls the state inside of the IBM cloud. This is great because in turn, you don't have to worry about managing state files anymore because it's all done inside of schematics on the IBM cloud. I should also mention that it is free. So if you ever want to play with it, and it just runs generic Terraform. So if you write Terraform to talk to AWS or Azure or IBM Cloud, it doesn't care. It just runs Terraform for you. So if you take a look, it's well worth it. And as I was going through this process, if I make this a little bit bigger, this is in essence what I created. So we have a internal GitHub instance right here that when an actor or someone who wants to request a cluster, they go to the GitHub Enterprise, which I will show this and walk through it here in a moment. But I'll walk through this diagram first so you can kind of get an overview. They go into this GitHub Enterprise, they put in a request through a GitHub issue. I have a cloud function, which is the equivalent of our serverless platform, or it's actually OpenWhisk, I think, that runs some validation against it to make sure that they don't go completely crazy by asking for like 1,000 clusters or whatever. This actually comes in and makes sure that it sits within certain amounts of guardrails, and then it tags it with a scheduled tag if everything is complete and good. And then we have a cron serverless function on something called Code Engine, which is the equivalent of IBM Cloud's Lambda, if you will, that sits there and every 15 minutes runs. And if it has the schedule tag, it actually looks to see if it's Kubernetes or OpenShift, hands it off to two different APIs that have two different versions of the Terraform required, because with Kubernetes, you don't need as many things as OpenShift needs. For instance, with OpenShift, one of the great advantages is you can build the containers internally inside of OpenShift. So you need backend support, I guess. Like what we use is COS, which is our object storage, but you can use like a PVC or whatever. So that requires more. So there's more Terraform for OpenShift than there is Kubernetes. And then we hand off to schematics, and schematics spins up the VPC, and then it updates the issue telling you, hey, everything's there, everything's running, and you're ready to go. If you notice, I didn't talk about this Grant Cluster API. This Grant Cluster is just basically a simple application that we hand off that allows you to check out clusters. It gives you a nice interface into it. So if you have an IBM ID, you know the passcode, you go in, you fill out the thing, you get a cluster for the N number of time of whatever you've requested here. And then it actually deletes everything for you too, which is pretty cool.
Okay, so question. Mm-hmm. What is the difference between Cloud Functions and Code Engine?
Good question. So
because you said, because what I heard from you was that Cloud Functions is OpenWhisk, and yes, Code Engine is IBM's response to Lambda. But yes, I thought OpenWhisk was IBM's answer to Lambda. So what's the deal?
So from what I understand, Code Engine is, sorry, 1 second. So Code Engine is actually built upon Knative and is a shared Knative infrastructure where you can just hand it functions or containers to run. Where Cloud Functions is built off of OpenWhisk, where you have to actually interface with the OpenWhisk interface to be able to do the functions inside of it, which I believe you can't run containers, which is a really important distinction for me here, because with CodeEngine, these are all just a bunch of containers that I'm running that I build and I just push up and they go do on either on a cron or whatever, where this Cloud Function is just a function, which I can show here in a moment, a Python function that parses all this information.
Okay, so the functions you're just giving literally like a blob of Python or whatever, correct. Whereas CodeEngine, you might have a blob of Python, but you're wrapping that inside of a container.
You can actually give it both, from what I understand. You can actually just push that Python file up into it, and it'll build a container and have it like run inside of the thing, just like Knative. Or in my case, I just run a bunch of containers in there that I've wrapped everything with all my dependencies. So I know that it just runs.
So why are you using both? Why wouldn't you just use CodeEngine? And
this was built legacy, and I didn't want to mess with it. It was just it does its job. I'm not going to mess with it anymore.
So the Cloud Function stuff was pre-existing, and you just added stuff into CodeEngine to be the glue into schematics.
Correct.
Gotcha.
There's nothing stopping me from ripping out of Cloud Functions and putting it in CodeEngine, apart from I know that this is stable, so I literally never have to touch it, so I'm just not touching it, kind of thing. Okay, so everything was based off of this VPC Gen 2. So the story goes is that, as I was saying with the building the Terraform, I had to figure out how to get Terraform up and running.
You got a little typo there, JJ.
Did I really? Where?
Yeah, VPC Gen 2 open stiffed.
Ah, nice. Good catch. Site feedback. I'd like to provide feedback on this page. Yeah, I'll get that fixed. So basically, as I was saying, I had to figure out a way to get all this Terraform to be programmatically created, right? So what I ended up doing is I learned, I've been delving deeper and deeper into Python because there's a lot of nice APIs or SDKs for it and all. So I started learning some Flask, and I quickly discovered that I could easily write a small little Flask application that took a blob of JSON, for instance, right here, and post it against my endpoint, and then fill out a bunch of options that I would normally need to do to request a bunch of clusters. So if you bear with me for a second, that is completely useless. So I'll grab this real quick just so we can see it. So if you take a look at this curl right here, do you make that bigger? Is that better? That's better. So if you look here, I just do this typical curl against the CodeEngine URL. I created the create API endpoint, make sure there's JSON. I give it an API key. I give it a workspace name, which is in essence, like short name for a workshop like OpenShift Lab or OpenShift Bootcamp or Prometheus or whatever. It doesn't really matter. I try to make it under 15 characters just because then you don't get crazy spaces and things like that. Then I give it a GHE key, which is our GitHub Enterprise key, so it can talk back to the actual GitHub Enterprise instance issue number. And then I give it a number of count of like how many clusters I want to spin up. So when I learned that, I figured I could do this by just shoving this into Python, or shoving this into Flask, and then just taking this blob and then just shoving out all the commands I needed to do. I realized this is in essence what serverless is, right? Is that it's a bunch of APIs talking to one another, creating in essence a massive Rube Goldberg machine that hands a bunch of information off one by one to different things to open and push forward. So if you take a deeper look into VPC Gen 2 OpenShift request API here.
I noticed there was no authentication happening there. Is that just because that's hidden?
Yes, all of this stuff is like gated, very far back. That you have to know exactly where you're hitting for my stuff to get to it, and you need application key or API keys to get any farther inside of it. So it's, you know, like there's so many things to get to the point where I don't actually need any real authentication in front of it, because like you wouldn't have access to the cloud, right? Like it's all done with API keys. So if you take a look here, this is what Paul was getting at. As you see with that create API, I have I pull in the posted data from the request.json, and then I pull out the API key. So even if you did know what my endpoint was, you need to know my API key to get to my backend. So that's there. There's the workspace, and then it logs in using because I'm using containers. I'm faking out virtualization in essence. So basically, this spins up a fake little Linux VM and just runs a bunch of system commands. As you can see here, logs in to the API, targets a specific target group for me. Also, make sure that you are inside my Grant cluster application, which is the overarching name we have, and then submits our job here with Code Engine to spin up the VPC Gen 2 OpenShift, which I'll show here in a second, which is actually all the Terraform and shit that happens. So I have a Flask app that's waiting for a JSON blob that's specifically tailored by me to hand off to schematics to spin up the instance. And then as you see here, give me 2 seconds. Sorry, my pump's beeping at me. As you can see, the delete is just in essence if you knew what schematics was, these are the commands to basically delete the schematics workspace. So with that, by creating that little container, so if you look here with the container cat Docker file, I just have a really simple Python app that sits here and listens on port 8080 and runs and just sits. And because Code Engine scales down to 0, I'm not paying for it until I hit that endpoint. And then it spins everything up, which is really nice too. So I have this container waiting. As soon as I hit that endpoint, Knative spins it up, takes that the request from port 8080, does the work, and then hands off to VPC Gen 2 OpenShift TF. This little repo right here, which is a little bit more in depth because again, you need to have the Terraform inside of it. And then does all the schematics work inside of this. If you take a look at the Docker file, as you can see, it installs Terraform inside of here. And then, which is actually not needed anymore. I should actually take that away. Then it updates a JSON file, which is this default.json. Every single schematics workspace has a default. When you create it, you can either create a generic one or you can create a JSON file with a bunch of sane defaults. And that's what I've done here with a bunch of sane defaults with like versions and stuff like that. And then the Terraform that gets ran is in essence just all of this stuff. The secret sauce here is all this stuff up at the top here are all the required portions to create your VPC. Unlike classics where I can just spin them up and call it a day. VPCs, you need to create a VPC, then you need to create a subnet, then you need to create security groups, just like you do on AWS. So figuring out all of this stuff for the IBM Cloud was challenging. Then also stripping out the portions I didn't need because again, I took this from someone else. And then I create a cost instance here where cost is our cloud object storage. So when you build your container on OpenShift, it ships it out to our object storage instead of a PVC, which makes life a little bit easier. And then pulls from that when you want to deploy that container on OpenShift. Creates the subnet and the gateway, Then a KMS instance, which is our internal key storage system. I don't actually know why this is required, but it is. So I create it, fine. And then here's where the actual magic happens with the clusters.
I would bet, JJ, it's encrypting the storage that's attached to the instances, and it's using a KMS key to do that encryption.
Okay. Yeah, exactly. That would actually make a lot more sense.
Well, it looks like you're not actually using the key. Go back up to where you created the key.
Yeah. This right here?
Right. So you're... So you're creating a key called test root key. Where are you then using that?
I don't know. I think it might be down in this here, right here. KMS instance. Right there.
Okay.
So yeah, and this is where the magic happens. Basically, we create a bunch of clusters that sit inside that VPC. The subnet has 256 subnet or IPs, which is plenty for a workshop, which is great. And then I put n number of clusters, usually anywhere from, could be anywhere from 10 to 50. The max I do is 75, but very rarely do we actually get up to that number. And then this just dumps them out, which is pretty neat. And then I do a wait till one worker node is ready, just to make sure that, I keep moving forward. I don't get stuck for the possible 8 hours that can take for our clusters to come up, which is a little annoying. And then I would show all the variables and stuff like that, but there's some keys in there, so I'm going to skip that part. But yeah, so in essence, now if we go back to our little diagram here, this is the Terraform, and that API gets talked to that. But let's actually talk about this cron issue tracker, where this is the core of the actual application, is this little system that constantly eats or reads this GitHub issues. So I'll bring up the GitHub issues first, just so we can keep that going. This is the repo that we use internally. As you can see, I have a couple workshops going on right now. So I create a new workshop request. I fill out this information, and let's call this streaming. Sure, why not? I make sure that everything's done in UTC, because UTC should be the way everybody does everything. That was supposed to be a joke. And then we'll do this at 2100, and then 11, 19, and then we'll do 10 clusters, and we'll do OpenShift, and then I will submit this issue. And as you see here, it's already scheduled. I parse the information, make sure that there's no issues. So if I had done like 100 clusters, it would have actually said, hey, it should between, no more than 75. Or the workers, for instance, OpenShift requires at least 2 workers. So we have some logic to make sure that you have at least 2, but no more than 4. Where Kubernetes, you can actually have 1 worker with Kubernetes. So we'll let this go. In about 6 minutes, we should see this thing kick off, because it happens. I have the cron that runs every 15 minutes. But while that's happening, I will go ahead and bring up the cron issue tracker, and then go into app here. So there is a lot of Python in here, I'm not going to lie. But the most interesting part is right here. So if you see, I do some work to scrape the repository. and then, or sorry, the repository. I look for scheduled and workshop, as you saw up here, scheduled and workshop, which is pretty neat. Then I parse the body to make sure everything's there where we expect it to be. I could actually take away this message one. That's kind of nice. I pull out all the information, and then I just start doing some logic here, where I look for the start time against it, and then I do the grant cluster request, as I was saying earlier. So it does that, kicks off, and goes off to the other API to say, hey, let's do that, and I'll show that here in a second. And then sends a cluster request to the correct place, and then sends a nice little message back to the issue to say, hey, I did it. Wait 4 hours to make sure it comes up how we expect it to. And then it even sets the label to running in workshop. So it hands it off to the next store, which is pretty neat. Let me double check something real quick to make sure there's nothing too secret in there. So if I do this, there we go. So if I come over here, and there was a bunch of the URLs were here, so I'm taking that away for obvious reasons. But as you see this right here, this is all because of Steve Martinelli, one of my cohorts. Amazing. He figured these things out where we can just basically do a post against the APIs with a couple of things in the payload, and then, figure this stuff out for us. Like right here is just the most generic way of updating a comment to an issue, which is pretty nice. And then here's that grant cluster request. As you see, knows the URL, goes ahead and fills out the exact same information, just like this grant cluster one right here. As you can see, OpenShift comes out on Kubernetes, it goes to the correct place. And then the delete is the same too. I mean, obviously there's a lot of repeated code in here, and I'm constantly trying to make it a little bit better, but it's pretty straightforward if you actually look through it. So that should have killed enough time. So in about 3 minutes here, we should see this kick off. Any questions, Paul?
Yeah, so it looks like from the code, you do the processing and then you call out to an API.
Yes.
Have you thought about using your object store as the way for the serverless apps to pass information along? Because often thinking about like Lambda, for example, often Lambda functions don't have an API. And instead they're looking for events that are happening in, say, S3. And then they take in data from the S3 change. Maybe they modify it, and then they put data back onto S3, and something else picks that up and works on that.
Yeah, I didn't even. Yeah, no, I'm just stepping into this world where I was creating a bunch of different APIs, just handling blobs back and forth. Right, like that's in essence. I mean, obviously, if I was doing something a little bit more, larger for an enterprise scale of something that would have to have like state over long periods of time. But right now, this stores all the state. My GitHub instance, right? Like all this information is the stuff I need to know.
Yeah. So I guess the reason I ask is because since you're calling an API, that effectively means you always need one copy of it running, or you need to have it on like a quick start so it'll spin up when someone does the API call, right?
No, not necessarily. So by having this GitHub validator to make sure that this runs off of a webhook off of the enterprise. So whenever somebody submits or updates it, it talks to this GitHub validator. So I assume that it does not get the schedule tag until this comes down with 0 issues request. That's me saying, yes, I can schedule it. And then my little cron here runs every 15 minutes. So that's when it spins up and starts paying attention and goes through looking for this logic within 24 hours of the start time. That's when it's allowed to do the work to like hand it off to the next thing down the line.
Right, but where it's handing it off down the line, it's doing an API call to do that. So whatever's down the line has to be always running.
Oh,
because
no.
because it's an API.
No, I do it down as scaled down to 0 thing. Hang on. So if you look here, and these are applications right here. So here we go. There's the streaming application of the Grant Cluster API just got kicked off.
Mm-hmm.
And we should see this update when this streaming right here is that Grant Cluster the API talked to the cron pulled all the information from the issue tracker, sends it to the Grant Cluster API. Grant Cluster API wakes up and says, oh, I need to do a request, sends out a new request to Code Engine to spin up the Grant Cluster application. Then the API, when it sees that it's done that, then it hands it off to whatever version of the next API that it needs to talk to.
Right. So the Code Engine then, it scales your API to 0s. Then obviously it has something that will hold a request until your API is up.
It's Knative.
Well, not everyone knows what Knative is.
I thought I talked about that earlier. Didn't I mention what Knative was? To scale down to 0.
Oh, maybe I missed it.
Yeah,
anyway,
I think that's when I first
so there's like some sort of like reverse proxy running as part of Knative, and when someone makes a call to your API, it looks at the URL and says, oh, I know which container needs to serve that, and so it will then spin up a copy of that container. Yep. And when that's up, it will then pass the API request to it.
Yep.
Yeah. Okay.
So as you see here now, 29 seconds ago, Tico came in and, created my little URL that I need to log in to do all that stuff. And then it'll take a couple more seconds because it'll have to spin up the OpenShift one. We should see this one turn into one VP CPU here in a second. I'm being very careful about my my keys now because I've spent a lot of work on this and I don't want to have to roll all those things. I've learned my lesson. There we go. There's the OpenShift API kicked off, and then successfully it actually talked to it, changed it to running, and now it's doing the work for me.
Nice. So explain this advo work thing to me. Is this a...
This is just a shared account on GHE that I just gave it keys and rights to talk to everything. So it's not me doing it. It's another account doing it. So I can actually get the emails. So when other people do it, it's not me just seeing it happen or me sending the requests or all
right.
That
but
stuff.
Like, does each app have a key to talk back to GitHub to make comments? Like how is this actually?
Oh no, that's actually done by this cron. This cron URL right here.
Gotcha.
This is the one actually that does all the actual heavy lifting.
Okay. So it grabs it, it parses it, it calls out. Now, what happens if the downstream API fails to wake up in time and times out or is unavailable?
I haven't gotten to that point.
Will it try again? Okay.
You haven't gotten to that point yet.
You haven't got like the retry logic figured out for that yet.
Yeah, not quite.
But obviously, also that probably means you haven't hit that as an issue, so you haven't had to spend time on it. Yeah. Okay.
Exactly. And I don't know why. Well, there it goes. So as you see, this is schematics right here, and we should have a streaming, as you can see, connecting, and it's already starting to build those clusters for us.
Nice.
So as you come in here, it does the Terraform plan for me automatically. Creates the workspace. Make sure there's no keys showing up. Creates the plan. Give it a second here. Come on. Come on. Maybe now.
Now, question about when the deletes happen.
Mm-hmm. There we go. There's the plan.
It happens because you gave a start and stop date, right? So it will, at the stop date, the cron job will see that it is past that date and will then delete the clusters.
Yeah. So give me 2 seconds here. The logic is right here.
Mm-hmm.
So I use the date format the same way, pull out the end time, start time, figure out now. If the end time minus now is less than 2 days, -2, which is weird math, I know, but it makes sure that it's at least 24 hours after the end time of you telling me it was done. So to make sure, for whatever reason, someone might be using it longer after it or whatever, and then it kicks off the delete request.
Gotcha. Now,
I know it's weird math, it really is.
One thing I've learned the hard way with Kubernetes clusters is people will spin up PVCs, they'll spin up services with load balancers, they'll do all sorts of, maybe there's an inbuilt registry that puts stuff into S3 or COS. How good is the Kubernetes cleanup?
Yeah, great question. The Terraform, from what I can tell, inside of the VPC, as you see, this all does within the workspace, right? So if something goes completely pear-shaped, for instance, if I go into this one, something goes into pear-shape, it will alert me and tell me something's gone wrong. For instance, this plan failed for whatever reason. And then, here we go. So my state's out of whack here. So I'm actually trying to figure that one out, but it's enough to be like, if I go back to the actual resource list here, look for overnight. It's a mitigated kind of situation here where I can say like, okay, look, here are a bunch of clusters for overnight here, which are tagged and ready to go. So, okay, yeah, 1, 2, 3, 4, 5 out of 30 are in a weird state. So I need to figure that out. Now I haven't gotten 100% yet, but 5 out of 30 is reasonable, especially when someone's asking for 30 and only like 10 people show up anyway. So it's gambling a little bit, admittedly, but I'm still kind of working on that one. But going back to schematics, we should start seeing workspace just to make sure one more time. Over in here we go. It's in progress. And then there's the apply actually happening. As you can see, the Terraform apply, make sure everything's there where we expect it to be. And then there we go. In chunks of 10, start spinning up all the clusters for me inside the correct VPC. And then
did it create a VPC for each cluster?
No, I put them all in one VPC.
Okay, but they each get their own subnets.
No, they're all part of the same subnet.
Okay.
I mean, these are ephemeral clusters. I would imagine that all of them are part of the same subnet. Shouldn't be too big of an issue.
Well, I mean, I guess how big is your subnet?
256.
256. Yeah. So if you have 50 clusters, each cluster is probably going to have at least 4 or 5 IP addresses for worker nodes, control plane, a couple of services, an API. So you'll wipe through.
Okay. Well, then I'll have to revisit that one. I'll have to revisit that one then.
Yeah.
That's not a big deal. Like that's just expanding the
Yeah. That could be why 5 out of 30 failed. Maybe maybe there weren't enough IP addresses in your subnets.
Ooh, that's a good point. That was a good point.
So my general advice to people is give each Kubernetes cluster its own VPC. And if there's reasons they can't do that, which is pretty common because often there's a lot of extra security stuff you do with a VPC, you do VPC peering and stuff like that. So it's harder to create and delete VPCs. And when that happens, I'm like, okay, well, in that case, at least make sure each cluster has its own subnet.
Interesting. Okay.
Because that way you then don't have to worry about them fighting over IP addresses. When you set machine siders and stuff like that.
Yeah, there's no reason why I couldn't take this and add the same these subnet, because I mean, if I'm correct, the subnets are just declaring down in here. Didn't I see it in here? Or is it the zone? Yeah, here we go. The subnet ID. So yeah, I could easily put the same kind of logic with a count in here, create a subnet for each cluster, each 30 clusters, all part of the same VPC, and then
Yeah.
attach it to each one. Yeah, that wouldn't be a problem at all.
Right. And then is there only one subnet? Like where does each node automatically get a public IP, or do you have a private subnet and a public subnet? How does that work?
That I don't know off the top of my head. But I'll have to play with this a little bit. But those is real. Like I create one public gateway for the VPC. Right there.
Right. So that's probably
right there. There it is.
So the public gateway is probably a like a NAT or something, right? And so that's how they route out.
But so how does create a gateway for each?
How does stuff route in?
Yeah, I don't know if I'm in.
Okay. You won't need to create a gateway per subnet.
No,
because the gateway is set for the VPC, not for a specific subnet. So if you look up here where you've created the gateway, you've specified a VPC in a zone, right? You haven't specified subnets. So this is going to be some sort of black box routing device that has an IP address that is able to be routed to from the subnets that they can set as their default route. So you should only need one of those, and you should be able to reuse that same gateway across your subnets.
Nice. Okay, cool. Well, I obviously have some homework to do now.
Yeah, but I think if you did your, like, if you put your count var in here and gave it the name subnet-count,
it's pretty much everything I need.
Then you do the same with the name, and then down where you're declaring what subnet to use, you would just need to do the same thing there to wire the two together. And I think that would probably get you almost, if not all the way to having the network isolation. And these are all like random privately addressed NATed networks, so there shouldn't be any limits to how many you have or anything.
No, and I would absolutely do that like right now, but I'm so paranoid about my keys.
No, I hear
you. I'm not going to do it, but that's exactly what I was going to plan on doing.
Yeah, and so the other thing to think about is there is some kind of overlay network running on the OpenShift clusters, right? And there's a good chance they're doing some kind of like anycast, multicast stuff to like figure out their networks and what goes where and what goes what. And so there's probably a lot of broadcast traffic happening. And so if you've got 30 clusters all doing broadcast traffic that they don't necessarily want each other to be seeing, I don't know if you'd run chances of like weird collisions there, or if in general you just end up with a super noisy network, whereas that broadcast traffic would be stopped at the subnet boundary, right? And so giving each cluster its own subnet would ensure that any kind of broadcast traffic like that or anything isn't going to potentially interfere with the other clusters. And then, of course, there's always a risk that if they're on the same subnet, that a person might be able to like address a service from another cluster and just like layer 4 straight across without any kind of routing or firewalling or anything happening.
Yeah.
Which, I mean, for workshops probably isn't a big deal, but it's still something that would probably be worth isolating them for.
Absolutely.
Now, you didn't really answer my cleanup question. So you kind of show that when you do the cleanup, you're basically saying, hey, IBM, delete this Kubernetes cluster, or delete these 10 Kubernetes clusters, right? And then when that happens, it will then... No?
What it does is it does the Terraform delete.
It does Terraform delete. And the Terraform is telling it to delete the cluster when the cluster's deleted, it will then tell it to delete the subnet. Then it
Yep.
will tell it to delete the VPC, right?
Yep.
But Terraform doesn't know about resources that the user has created in Kubernetes. So if I'm in your workshop and I create 100 PVCs,
you're attached to that Kubernetes cluster though, and I do delete inside of here. Hang on. Force delete any storage. So for instance, like the PVC, anything attached to the clusters get deleted for that one.
Okay. Yeah. All right. That makes more sense. Yeah. I've seen like shared accounts in like AWS and stuff that people are spinning up EKS clusters and whatever up and down constantly, tend to gradually grow weird resources that aren't cleaned up the way the internet promises they should be. So that's always something I look at and try to think about.
Yeah, no, it's good. That was a very good question. Very good point. Yeah. And I, by default, I'm like, if anything's attached to this cluster, get rid of it. Right. If it's deleting, I don't care. Just get rid of it.
Yeah. Does it? I wonder if it does like how smart its delete cluster is. Does it go and look at namespaces and delete resources, or is it just like YOLO it out?
If I remember correctly, everything goes off of something called a CRN. Every cluster gets assigned a CRN, I believe. I'm trying to find it. And then every resource that gets assigned to that CRN, it backwards reads it and looks for anything that's been like it does a find basically, looking for anything and then deletes it. Granted, it isn't 100%. I have seen hanging resources before, but the beauty of this cluster, this account, is that nothing ever lives longer than 72 hours. So if I have no workshops going at all, I can go through the whole thing and just be like, delete. I mean, hell, I think I even have it in my history, right? And just like, delete everything. I don't care.
Right. Kind of thing. Nice. In Azure, they have the concept of resource groups, and they're so good. You're just like, I don't care, just delete the resource group, and like everything just goes away. It's so nice.
Jay Destro showed me that, and I'm like, all right, Azure's got something pretty cool here. That makes my life so much easier. So awesome. Well, I mean, that's it in a nutshell. That's all kind of wanted to show.
Cool.
I mean, we don't have anything else really planned for today, just because it's about to be Thanksgiving, Thanksgiving break here in the U.S. So obviously we're not going to be here next week because next week is Thanksgiving.
Oh, we're not gonna stream Turkey Day.
Oh God, no! I don't actually know where I'm going to be, so we'll we keep going back and forth on where we're going, what we're going to do.
Fair enough.
We'll see. All right, Paul. Got anything else?
No. I think we can call it a day.
Cool. All right. Well, thanks y'all for sticking around. And I'm actually going to get this video uploaded to YouTube, and then I'll probably actually put it on that blog because we actually walked through the whole thing. So
nice.
Why not? So that'll work.
Cool. Awesome.
Say bye, Paul.
Bye, Paul.